Okay, hello everyone. And welcome into Unit 4. Okay, Unit 4 is going to be all about permutations and combinations. Okay, so we're going to talk a little bit about each of them today. Actually, we're going to talk about permutations today. We'll get to combinations after our quiz for this unit. Okay, so the first thing we're going to be talking about are counting principles. Okay, so in this unit, we're going to examine methods of counting, the number of possibilities for any given situation. For example, how many ways can three different textbooks be arranged on the shelf in a row? Okay, so say you have a bookshelf here, and on the top shelf, I'm going to put three books. Okay, I got one book, two books. Oops, oops. Sorry, something. Oh, wait, does this have closed caption? Okay, let me turn that off. Sorry. And three books. There we go. Okay, so how many different ways can we arrange these three books in a row? Well, if I call this one A, this one B, and this one C, we can start to kind of map it out. Okay, so that's the first way we can do them. We can have book A, then book C, then book B, then book C. But we could also flip these two, right? I could have A, C, and then B. Okay. What if I want to put B, the yellow book B first? I could go B and then A and then C, or I could flip them again, go B, then C, then A. Maybe I want book C first. Maybe that's the first book of the series. I'll put C, A, B, like a cab, or I can go C, B, A. Okay. Do you think there's any other ways that we could order them? Because if we go back to A, we already have A, B, and then C. Then A, C, B. We can't do any more with A. Can't do any more with B in the front either, or with C in the front. Okay. So there are six ways. Therefore, there are six ways that they can be arranged. Oops. Therefore, there. Okay. The other thing that we could do, or what you can do is, we do this a lot, where in the first spot, we could have one, two, three different options. Okay. So for our first spot, there are three options that we can use. In our second spot, so say I fill up the first book with B, the first spot with B, then I either have A or C left. A or C. If I fill the first one with A, then I have B or C left. Same thing for C. Okay, so then I have two books that can go into the second spot. Okay, and then in my third spot, I'm only going to have one option left. Okay, so if I start with B and I put C next, I can only put A left. That's the only book I have left. Okay, so I'll have one book left for that spot. Okay, so if you multiply 3 times 2 times 1, we get 6. Okay, so it's two different ways of solving the same thing. And this is actually 3 factorial, which we're going to talk about in our next lesson. Okay, so we'll be using like this kind of method a lot throughout this unit and a little bit in Unit 5. Sometimes it can get a little bit tricky. So again, as always, if you have any questions, please send me an email or come to the Google Meet office hours. Okay. Also, I kind of wrote over this, but once we solve the simple problem, we can extend this thinking to larger, more complicated problems. Okay. So instead of doing like this every time, we can start doing things like that where it's a lot faster to calculate the total. Okay. So in this section, we're going to be looking at two fundamental counting principles, or the fundamental counting principle and the rule of sum. Okay. So let's do another example. We're going to use a tree diagram to list the possible outcomes when a coin is tossed 4 times. Okay. So if you don't remember what a tree diagram looks like, we're going to do one together. Okay. So the first toss, we can either have, for a coin, we can either have heads or we can have tails. So I'm going to try and space this out because it's going to get quite cluttered. For the second toss, we can, so say we flip heads with the first one. When we flip it again, we can either have a head, two heads in a row, or we can have, actually, I'm going to make it down a bit more, so a little bit more room. We can have a head, or we can have a tail. Okay, so that's where the tree diagram kind of comes into play because it branches out. Okay, let's say we got a tail on our first one, then you could flip either a head or another tail. Okay, if we do it a third time, the third toss, from this head, we can either have another head or we can have a tail. So it branches out again. So we can go head, 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 or we can go heads, head, and tails. Okay, or if you go heads, tails, you could go heads again, or you could go tails. If you go tails, heads, again, we have heads, or we have tails. Go tails again. If you go tails, tails, you can have heads or three tails in a row. Tails, tails, tails. Okay, and this is the part where I said it's gonna get a little like cluttered. We have our fourth toss. So we can have head, we can have a head, a head, a head, then another head. Or we can go three heads in a row and then come up with the tails. We can go heads, heads, then tails, heads, or heads, heads, tails, tails. Okay. Sorry, it's going to get a little cluttered here. I'll do my best to kind of keep everything separate. So basically, after each toss, you have two more combinations that get kind of added on. But what happens is we're going to end up multiplying them all, okay? Heads, tails, heads, tails. I have to cut this one short. Head, and then tails. Sorry, it's kind of really cluttered there at the end. Okay, so if you want to write the result, actually, let's do this in a different color. We'll go red. Okay, we go heads, 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 heads. So our result would be H, 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 H. So we have four heads in a row. Or we can have head, 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 and tails. Or we could have gone heads, heads for our first two, then a tails, and a head. Or heads, heads, tails, tails. Okay. So if you write out all of these different combinations, you can write them all out on your page. I'm just going to run out of room. I'm just going to go dot, dot, dot. To the very end, we would get tails, 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 and tails. Okay. And if you add them all together, there would be 16 outcomes. Okay. So we can kind of count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. So what I'm doing is just counting everything. I'm just counting the end result because each one leads to a different path. Okay. The branching through our tree diagram allows for all these different branches. Okay. And all these different outcomes. So we have 16 different outcomes. Or again, if we just multiply it, our first result could have been a heads or a tails. Heads or tails, we have two options. Okay. Our second outcome, again, is heads or tails, or heads or tails. So we have another two options. Then the third one, two options. Third one, two options. So we just multiply them all together, and that also equals 16. Okay. So this in the green is a lot easier than all the blue and red. Okay. So that's where we start to get into the fundamental counting principle, which is also known as the rule of sum, or sorry, rule of product. Okay, so get it more into that in just a moment. Let's do another example first, okay? So a die is tossed and then a coin is tossed. How many possible different outcomes are there? Okay, so let's do a tree diagram first. Oh, let's just say, yes, I want to stay in the call. Thank you very much. Okay. Like blue. So we're going to do a die. So when you roll a die, there's 6 sides to a die, or dice plural. So we can have 1, 2, 3, 4, 5, and 6 for our die. Okay. And next, we're going to toss a coin. Not to your witcher, we're just going to toss a coin. Okay. So when we toss a coin, say if we roll a 1, our next option could be a heads, or we could have a tails for the coin. If we roll a 2, we can have a heads, and then, or we could have a tails. Have heads for 3 or tails for 3. 4, we can have heads or we can have tails. Heads for 5 or tails. Heads for 6 or 6 could be a tails. Okay, this one's a little bit less cluttered. Let's count how many different outcomes we have. We have 1, 2. We have 1, then heads, 1, then tails. 2, then heads, 2, then tails. 3, then heads, 2, 3, and tails, and so on. So how many different outcomes we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's 12 different outcomes here. Therefore, 12 different outcomes. Okay. Whoa, I have way too many circles, half circles on that end. Outcomes. Okay. Or again, or. Okay. So we are rolling a die and then tossing a coin. Okay. So when we roll a die, there's 6 different outcomes. And when we toss a coin, there's 2 different options. We have heads or tails. And then what's 6 times 2? 12. So therefore, there are 12 outcomes. Okay. So instead of making like big tree diagrams every time, what we're going to do is start doing no kind of multiplication bits that look like this. Okay. So how else could we arrive at the answers from the above examples? Well, these are all the green methods that I was doing there. Okay. So we can multiply together. Okay. So we can look at how many different outcomes each event has and then multiply together. Okay. Look at outcomes of each event and multiply. Okay, that's what we're doing. We're saying how many different ways can this happen and then multiply it, everything together. Okay, and this is our fundamental counting principle or the rule of product. Okay, so these are questions that are going to have and in them. If something happens and something else, then we multiply together. Okay, so in kind of mathematical terms here, if the first action can be performed in m different ways, and a second action can be performed in n different ways, then both of these actions can be performed in this order or in some order in m times n ways. Okay, so m times n. Okay, so that's why it's the rule of product, because we're multiplying together. Okay, and this principle is not limited to only 2 actions. If we have the first action can be performed A ways, second action can be performed B ways, the third action can be performed C ways, then all these actions performed in a certain order would be A times B times C. Okay, so A times B times C. So we're multiplying everything together. Okay, so this is multiplication. Multiplication, perfect. Okay, so let's do an example now that we know what we're actually talking about here. Okay, so at Holy Cross, this is the school I teach at. Uh, Female students may wear a skirt, pants, or shorts, and they can wear a t-shirt, an oxford, a polo top, or a sweater. and they can have green, white, or black socks. Okay. And how many different ways can female students dress themselves or outfit themselves at the school? Okay. So what we're going to do is we're going to say, okay, let's look at their bottoms first. Okay. Their bottom bit of clothing. Okay. So the bottom half of their clothing can be skirt, pants, or shorts. So we have 1, 2, 3 different options for them. Okay. If we look at the top of their clothing, okay. So what kind of top can they wear? They can have a t-shirt, an Oxford, a polo, or a sweater. Okay, so they have 4 different options for the top. Okay. And then for their socks, they can have white socks, or sorry, green, white, or black socks. So if we look at socks, there's 3 different options for socks. Okay. And now, because it's all and, we're going to multiply together to see how many different ways they can outfit themselves. Okay. So if we take 3 times 4 times 3, that would give us 36. Okay. So therefore, there are 36 possible outfit combinations. Okay. And then, yeah, to circle it. But usually on your test, I'll just give you like a blank box. So if you just put 36, that's fine. Yeah, just 36 by itself is good. Okay. So what we want to do is we want to break down each event. So like in this part, we're going to look at the bottom half of the uniform. We're going to look at the top half of the uniform and the socks for the uniform to see how many different ways uh, they can form an outfit combination using the school uniform. Okay. Next, Rob hopes to select a black face card and a red ace from a full deck of cards. Okay. And how many different ways can this be done? Okay. So if you're unfamiliar with a deck of cards, what we have are there's 52 cards in the deck. Okay. And I'll be sure to post like an image of a deck of cards in this unit just so everyone has a reference to it. Okay. So there's 52 cards. Okay. So there's 26 red cards, 26 red. Okay. And there are within this 13 hearts and 13 diamonds. Okay. And then there's 26 black cards. There are 13 spades. Oh, God. I cannot really draw a spade. And 13 clubs. Oh, this one's going to be even worse. Oh, that kind of looks like a clover, but it's kind of a club. Okay. So there's 52 cards. 26 of them are red. 26 are black. And each have 2 different suits. Okay. So there's 4 suits total. I'll do that one in blue. 4 suits. And the suits are hearts, diamonds, spades, and clubs. Okay. We're not going to talk about like jokers or anything like that. Okay. So it's 52 cards total, 4 suits, 13 of each suit, and the suits go from it goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have the jack, the queen, jack, queen, and then king. My pen went faster than my mouth did there. Jack, queen, king. Okay. And these 3 are considered face cards. Okay, because they have the face. They have a face of a jack, face of a queen, and face of a king. Okay. So if Rob wants to select a black face card, or a red ace from a full deck of cards, how many different ways can this be done? Okay, so each suit has these 13 cards. Okay, so if we are looking at a black face card, how many different ways can this be done? Well, for each suit, we'll have a jack, king, or jack, queen, and a king. Okay, so if we're looking at how many different ways we can have them, so we'll have 1, 2, 3 for the spades and 1, 2, 3 for the clubs. So there are 6 total black face cards. We'll have the jack of spades, jack of or queen of spades, king of spades, and then the jack of clubs, queen of clubs, and king of clubs. Okay. And then how many red aces can we have? So red ace. Okay. So each red suit will have an ace. So we have an ace of hearts and an ace of clubs, but that's it. Okay. So we have 2 red aces. Okay. So if I multiply these two together, or sorry, we're not multiplying here because he wants to pick a black face card or a red ace. Okay, so this or is important. The or is different from and. The or means that we're going to add them together. So he wants either like the queen of clubs or he wants an ace of hearts. Okay, so because he wants one or the other, we're going to add them together. So it'll be 6 plus 2. So there are 8 ways that this can be done. Okay, so that leads us into our rule of sum. Okay, so this is the or is when we add. Okay, if one action can be performed in m ways again, another action can be performed in n ways, then these two options cannot occur simultaneously. Okay, so just going back to this one, we were looking at a red card or a black card. We weren't looking at one of each. Okay, so they're kind of 2 independent events that can't occur at the same time. Okay. Then either of these actions, so either one or the other, can be performed in n plus n ways. Okay. So if there's overlap, then we don't have a rule of sum. Okay. And it can also be extended to more than 2 events. Like if we wanted to have A plus B plus C plus whatever, you can do it that way. Okay. So if there is overlap, you have to subtract the overlap. Okay. So you can still add them together, but subtract overlap because otherwise you'll kind of double count one thing, okay? So subtract the overlap. Okay. So let's go back to here. So how many ways can you select an ace or a black card from a full deck? Okay, so going back, again, 52 cards, 4 suits. All of them go from ace to 10, then jack, queen, king are face clubs or face cards. And we have 26 red cards and 26 black cards. Okay. And how many ways can you select an ace or a black card from a full deck? Okay. So let's just look at the ace first. How many aces do we have? We will have the ace of hearts, the ace of diamonds, ace of spade. This actually this would be clubs. Ace of clubs, and the ace of spades. There we go. That's the best you're gonna get of me. Sorry, guys. Okay. So how many different aces are there in the deck? Well, there's 4 aces. So these are 4 aces. Actually, how many different ways can we get an ace? We can get an ace 4 different ways, one from each suit. Okay. Times how many different ways can we get a black card? So for a black card, remember there's 13 clubs. 13 clubs and 13 spades. Okay. So how many are there together? Altogether, there are 26 different black cards. Oh, sorry, I'm not multiplying. We are adding because we want, again, or. We want ace or a black card. Okay. Now, hopefully you notice that we're going to have to do something because one of these 13 uh, clubs is an ace, and one of these 13 spades is an ace. Okay. So we can't just add these two straight up together because otherwise we'll count these ace cards twice. We'll count them once when we count the aces, and we'll count them once when we count the black cards. So we have to subtract the overlap. Okay. So we have to subtract the overlap, which are these two. Okay, our two black aces. Okay. We have to subtract 2 because there's 2 of them here. We don't want to double count them. Okay. So we just count for however many overlaps there are. We have 2 overlaps. We just have to subtract 2. So we do 4 plus 26 minus 2. So there's 28 ways. Okay, so there's 28 different ways that we can select either an ace or a black card. Okay, because we have 26 of these and then 2 red aces on top of that. Okay. So just remember, we just have to subtract the overlap. Overlap. Okay. So we've seen that a lot more when we get into like factorials as well. But that is it. Yeah, I'll keep it for now. That's it for this lesson. Please let me know if you have any questions. This unit kind of starts off easy, but once we get into more about permutation and combinations, the questions can become a little bit more complex. So just let me know if you have any questions, either by email or in the Google Meet. Okay. Hope you're having a great day, and we'll talk to you when we talk about factorials. All right. Bye.